Hello everyone, and welcome to this lesson on deep learning with PyTorch. So in this lesson, I'm going to be showing you how we can build neural networks with PyTorch and train them. By working through all these notebooks I've built, you'll be writing the actual code yourself for building these networks. And by the end of the lesson, you will have built your own state-of-the-art image classifier. But first, we're going to start with basics. So how do you build just a simple neural network in PyTorch? So as a reminder of how neural networks work, in general, we have some input values. So here, x1, x2, and we multiply them by some weights, w, and a bias. So this b is this bias. We just multiply it by 1. Then you sum all these up, and you get some value h. Then we have what's called an activation function. So here, f of h. And passing these input values h through this activation function gets you your output y. And this is the basis of neural networks. You have these inputs, you multiply by some weights, take the sum, pass it through some sort of activation function, and then you get an output. And you can stack these up so that the output of these units, of these neurons, go to another layer, like another set of weights. So mathematically, this is what it looks like. Y, our output, is equal to this kind of linear combination of the weights and the input values, w's and x's, plus your bias value b. It passes through your activation function f, and you get y. You can also write it with this sum, right? So sum of wi times xi and plus b, your bias term. And that gives you y. So what's nice about this is that you can actually kind of think of the x's, your input features, your values, as a vector, and your weights as another vector. And so this sum, this multiplication and sum, is the same as a dot or inner product of two vectors. So if you consider your input as a vector and your weights as a vector, if you take the dot product of these two, then you get your value h, and then you pass h through your activation function, and that gets you your output y. So now if we start thinking of our weights and our input values as vectors, so vectors are an instance of a tensor. So a tensor is just a generalization of vectors and matrices, right? And so when you have these like regular structured arrangements of values, right? And so a tensor with only one dimension is a vector, right? So we just have this kind of single one-dimensional array of values. In this case, like characters, right? tensor. And a matrix like this is a two-dimensional tensor. And so we have, values going in two directions, from left to right and from top to bottom. And so then we have individual rows and we have columns. And so you can do operations, across the columns, like along a row, or you can do it across the rows, like going down a column. And you also have three-dimensional tensors. So you can kind of think of an image, like an RGB color image, as a three-dimensional tensor. So for every pixel, there's some value for for all the red and the green and the blue channels, right? And so for every individual pixel in a two-dimensional image, you have three values, right? So that is a three-dimensional tensor. And like I said before, tensors are a generalization of this. So you can actually have, four-dimensional, five-dimensional, six-dimensional, and so on, like tensors, right? It's just the ones that we normally work with are one and two-dimensional, three-dimensional tensors. So these tensors are the base data structure that you use in PyTorch and other neural network frameworks. So, TensorFlow is named after tensors, right? So these are the base data structures that you'll be using. So you pretty much need to understand them really well to kind of be able to use pretty much any framework that you'll be using for deep learning. Okay, so let's get started. I'm going to show you how to actually, create some tensors and use them to build a simple neural network. So first, we're going to import PyTorch. And so just import torch here. Here I'm creating an activation function. So this is the sigmoid activation function. It's the nice S shape that kind of squeezes the input values between 0 and 1. And it's really useful for providing like a probability, right? So probabilities are these values that can only be between 0 and 1. So your sigmoid activation, if you want the output of your neural network to be a probability, then the sigmoid activation is what you want to use. Okay, so here I'm going to just create some kind of fake data. I'm generating some data and generating some weights and biases. And with these, you're actually going to do the computations to get the output of a simple neural network. So here I'm just creating a manual seed. So I'm setting the seed for the random number generation that I'll be using. And here I'm creating features. So features are like the input features of the input data for your network. Here we see torch.randin. So randin is going to create a tensor of normal variables, so random normal variables. It samples from a normal distribution. And you give it a tuple of the size that you want. So in this case, I want the features to be a matrix, a two-dimensional tensor of 1 row and 5 columns. So you can think of this just as a row vector that has 5 elements. For the weights, we're going to create another matrix of random normal variables. And this time I'm using randin_like. So what this does is it takes another tensor and it looks at the shape of this tensor and then it creates it. It creates another tensor with the same shape. So that's what this like means. So I'm going to create a tensor of random normal variables with the same shape as features. So that gives me my weights. And then I'm going to create a bias term. So this is, again, just a random normal variable. Now I'm just creating like one value, right? So this is 1 row and 1 column. Here, I'm going to leave this exercise up to you. So what you're going to be doing is taking the features, weights, and the bias tensors, and you're going to calculate the output of this simple neural network. So remember, with features and weights, you want to take the inner product, or you want to multiply the features by the weights and sum them up, and then add the bias, and then pass that through the activation function. And from that, you should get the output of your network. So if you want to see how I did this, check out my solution notebook, or watch the next video, which I'll show you my solution for this exercise.